Welcome to Data plus AI Summit 2020. Our topic for today is Advanced SQL for Data Scientists. By the way, I am Jean-Joseph. I've been in IT for over 18 years. I started as a network administrator. Then I became database administrator and developer. After that, I moved to data engineering. This is my blog. This is my email. And then I'm on Twitter. You guys feel free to follow me and connect with me on LinkedIn. I am located in New Jersey, currently from Haiti, originally from Haiti. Okay. Our overview for today is a brief introduction to SQL, data preparation in SQL, preparing data for use. Okay. The five major things to know in RDBMS, SQL Advanced Filtering, and Keynote. Right? Um, First of all, we cannot talk about SQL without, talk about introducing RDBMS, which stands for Relational Data Management System, which, where you will be dealing with tabular data, where you will see rows and columns, right? And you will be able to create tons of objects like tables, views, synonym, functions, procedure. And then there are two types of them, normalization and denormalization. Normalization is where you will find less duplicate data, and then that we consider this just like OLTP, which stands for online transactional processing. And for denormalization, our data warehouse is normally denormalized, where you will be dealing with a lot of duplicate data, right? And then things that you need to know is that our DBMS system maintain consistency using ACID. Okay, what is SQL, guys? SQL is the language that allows us to communicate with the database. It stands for Query Structure Language, right? It allows you to control, create, modify, object, and manipulate data. What, what really can we do with SQL? In order for you to master SQL, you need to understand the data language. The data language is what will help you master SQL. The first data language you need to understand is DDL. DDL stands for Data Definition Language that will allow you to create, job, truncate, alter, comment, and rename. The second one is DQL, which stands for Data Query Language that will allow you to retrieve data from the database. The third one is DML, which stands for Data Manipulation Language, where you will be able to insert, update, and delete. The fourth one is DCL, which stands for Data Control Language, that will allow you to grant or revoke access. And the fifth one is TCL, which stands for Transaction Control Language, that will allow you to maintain your own behavior. Like instead of using the default one from SQL Server, you will be able to override this. You can sometimes a transaction may depend to some other transactions. You can even save point. You can use set operations, right? However, when you add DQL together with DML, you get what called quad. Quad for create, which come from a DML, insert a record, and then R stand for read, which comes from query language, which is select. U is update, and D is update, and both of them belong to data manipulation language, right? So as a data scientist, should we worry about definition and control language? No. Where should we focus? You should focus on quad, and you have to master this. And then you need to have a deep understanding of TCL, right? Okay, why SQL for data scientists? Data is the most crucial part of data science. even business, correct? You can't have data science without data. And SQL is what will allow you to communicate with the database. So you need to be able to master it, right? This is just a recap. How can you join different tables? You have to think of join. There's inner join, left join, right join, and then full outer join. Inner join will return data only where your conditions happen to be true. The left join will return data from the first table, even though if the condition is true or not, the whole data will return, right? Including the data from the second table where the condition happened to be true. Right join work similar like left join, but it goes the opposite way. So it will return data from the second table or right table, including all the data from the first table or left table where the conditions happen to be true. And full outer join will return data for both for data set. Wherever the condition is true, you have data. Wherever the condition is false, null will came out. There's cross join where, let's say if you have two table A and table B, you want the first column to join all the column from the second table, cross join is there. And sometimes you can use it to replace while loop. Beside that, right, as this is the demo will be on SQL Server, you need to understand the apply operation where there is cross work just like left join, and there is outer work just like right join. And then also there's pivot that allow you to change the format of the data. Things that you need to know if you want to join two data sets with no conditions, there's union all. Union all is great for that. And union all will give you duplicates. Union will not give you duplicate. There is except. Except return the data in a set A for, let's say if you have two tables, A and B. So except will return the data and there will be no overlap. Things you need to know for intersect, there will be overlap within these two tables, right? And then for data preparation, things that I want you to understand is that data preparation is a pre-processing steps, right? In which data from one or more sources is cleaned and transformed to improve data analysis, correct? But there is stage. The first stage in data preparation is the collecting data, right? Data collection technique is information you gather can come from a range of sources like observation, interview, survey, or questionnaire. Case study database. In our case, it will be database, right? During the data collection, you have to determine your objective, what exactly you are looking for to achieve. You have to determine who are your samples or respondent are, right? So what exactly they are waiting for from you when you're collecting the data from them. Things that you will need to understand. The more effort you put into data collection, that greater effort leads to better data quality, right? The second thing is cleaning data. Cleaning data is where you're gonna spend most of your time. You will need to find all your outliers, missing data, malicious data, where you will need to find inconsistent data, formatting data, right? And you will also make sure you bring clean data. But if, for example, you bring bad data, what you need to understand is that garbage in and garbage out. It's always best to look at your data, examine it, question your results set. And you need to do that, right? And then the third thing is restructuring data. Restructuring data can be defined as the group of data, right? Which provide an efficient way of storing and organizing data in the computer so that it can be used efficiently. Few functions that I want you to understand when it comes to data preparation. There is position functions, there is transformation functions, there is a character set function, and there is also sound index function. If we're looking at here, these are all the functions, guys. You guys can go and do some research. This is a 2-hour sessions, and I have to bring it down to 30 minutes. So I hope you guys understand me. Okay, the reason why I have this very early is because I want you to understand, because everything else will be demo, the difference between aggregate versus windowing functions. Aggregate functions will operate on entire data set or table, if you will, and you have to use group by. If you don't use group by, right, it will erase out. And whereas windowing function do not cause a word to become grouped into a single output, right? Instead, it's operate and an aggregate value, right? We'll add it to each word. So this is the syntax for windowing functions, right? And then these are the type of windowing function. We have aggregate windowing function, ranking, we have value, right? Let's go to some demo. Let's say, for example, you have this data. In real case, we're gonna have tons of data, correct? Business wants you to know where, business wants you to extract. This is a great, extract grade from this is a great event, right? So what happened? The first thing you will need to know is to know where that grade is located. This is where car index will help you. So what happened? Let's keep it simple here. So the expression to find is great. And then the expression to search is, this is a great event. We were able to get that left, the location of grade, right? Let's say if the goal was to extract it. So what happened with the help of substring, as you can see, we don't have time to go over the parameter. So what I'm doing here is that the parameter is to pass first of all, the string, and then give the start location. With the help of car index, we were able to give it. And we know it's 5 characters. There's no need to dynamically, maintain it. We put 5. So if you're looking at here, we got 5. So let's go a little bit complex. What happened if you have this data set where business want it to be? For example, you need to find any keywords that start with big and end with driven.org. How would you do that? You cannot use car index, but instead you can use pod index. And then if we're looking at here, big data.org will not be displayed, correct? So this is how you can use a pod index. It's use regular expression, right? What I'm doing here, I'm dumping the data into a table variable. This way we can see that data set. I'm using substring and using pod index, right? And then using car index and pod index to dynamically locate it where the string is located. And then when I execute this, sure enough, you will see the second result said we didn't bring big data.org because there's no driven in it, right? And then let's say if you have, if business have this format, it want it to be this format. String aggregate should be your best friend. So as you can see, I use string aggregate here, right? I pass the delimiter. I was able to do that, right? Let's say, for example, you have this data. So now business want it to be this way. How would you do that? This is where string split will help you. And it is very simple to use. So what I'm doing here, I am, this is the data I'm generating into a temp table, right? And then this is, I'm using quantiply against that data. And then I was able to bring the value. So if you're looking at here, the format business one, I was able to provide that. So this is the thing that I want you to know. How easy would it be? And with a very few codes, you were able to achieve this. So when it comes to SQL aggregate functions, there's a tons of them. There's aggregate, there's analytic, there's windowing functions, things that you will need to know When it comes to windowing function, the default is range. Range will be if operate in temp table, in temp DB. Sorry about that. So that's mean there may be performance impact. Whereas rows will be into the memory, and I would highly suggest you to explicitly type rows instead of use the default one, right? So let's go and do some demo. Let's say if the business requirement, for example, is to provide the total sales. So business want to know all sales order for each year. And then this is the year. As you can see, this is year. I'm using year function to get that. And then to calculate the sum of the total due, I'm using the sum here, right? And then the total average of sales order, I'm using the average here. And then also the total number of sales by year, right? I'm using the count here. And also, you just want to know how well the product are selling relatively to other year. As you can see here, I'm using rent function and ordered decimal. So I want, for example, the year that we made more sales happen to be one, correct? And I have to go by here again and order it by sales, order by here, right? When I execute this, this is what I got. Marketing team can quickly see in 2013 was the time we made a huge sales. They can quickly reanalyze and see, do we have less customer? Do we still have those kind of customers? There's so many things they can go and use that data for, correct? So let's say if you have to running the daily total and then business wanted to be for a specific date. In our case, it's June 1st, 2014 onward, right? And we have to order that data. How would you do that? With SQL, it will be very, even though it is an advanced session, when you're looking at this, it is very simple, correct? You see, I'm using aggregate function. Sum, which is total due, and I order it by sales order ID and use row unbounded descending, and then this will give me the warning total in this in ascending. As you can see, in the first sales was $8.78. If you're looking at the second day, we that same day we sold another thing for $33.12. If you add all of them, you have that 41, right? So this is how easy you can run running total in SQL Server. Let's say if marketing team, for example, asks you to return the first three order plus the close price, the total order due, total orders for every customer that purchased more than 50 times. So the goal is to find all order details. I'm selecting this data, customer ID, and I'm using count, right, and partition by order ID and order by customer ID to give me the total order per customer. And I'm using row count, order by customer ID, and order by partition by customer ID, and order by sales order ID to give me the row number, because in windowing function, I cannot use where close. I have, to use a subquery. In my case, I have to use, sorry about that, CTE to bring that result. So what I'm doing here, I'm selecting from that CTE where row is less and equal to 3, and then in total order is greater than 15. And then true enough, when I execute, you will see the first three results set. And if you're looking at one customer purchased 17 times from us, we were able to bring only the first three times they purchase from us. And then if you're looking at the third example, that customer purchased 28 times from us, we were able to bring the first three times or the purchase from us, correct? Let's say if there's another requirement where business have asked you to return all order from sales order header table for any customer who had over 10,000 in purchase, right? So what I'm doing here, for the first three transactions. This is kind of similar, but the thing is they want me to bring to return all order from the order details. So that's when if you're looking at this, we have to find the first three customer because I cannot use workloads here, and then we have to aggregate the first three orders. You see, I declare the first CTE, right, to give me the whole number, and I'm using that CTE, and you declare another CTE, right, within that same query, okay, and then filter it by where row number is less than equal to 3 because they want me to include all other details. So I will need to join this table back, this value with the table, with the original table in order to bring the other transactions, right? So when I execute this, if you're looking at this one, sorry about that. If you're looking at this one, right, you will, if you add the first three times the purchase from this query, from this result set, you will see it's equal to $10,593, right? And then if you go to the second customer, it's still the same, right? Marketing team can use that data to go and do some promotion, do some complex operation, and then we think SQL, that's how easy and with very less code and you're not only dealing with less code, but you have better performance as well. And then let's say if business wants you to find the first and the last close price for each day of every month of the year, including every single details, how would you do that? This is where you have to think of the first value and the last value, right? What I'm doing here is that I'm partitioning by month and year and order by order date. And I'm doing the same thing for this one. When I execute this query, I was able to provide the first close price and the last close price. If you analyze the data for every date, you will see it is still the same, right? We were able to bring the first and the last close price. So let's say if you have this data and then the goal is business want this data to be this way, right? They need it to be calculated for each month and get the subtotal for each year by region and territory. How would you do that? This is where you will think kind of different way, right? So we will use case statement to, make the magic happen. So what I'm doing here, as you can see, there's no time, guys. You can go, because I already shared that slide that you can go and understand the script, but the result set of this guy will give you this. For each year, we will, for each month, we give the month total, and then for each year, right, we give the total, how much every customer, purchase from us, the total for every year and the total for every month for every customer. As you can see, the script was not that complex. If you have to use Python or any other languages, you can see how complex would it be. So things you need to know is that as a data engineer, you have to understand quad, understand ACID, understand TCL, and also understand query optimizer, when to use index. The thing that I always like people to think of, always have a way to handle your exceptions. And then you need to have, the key takeaway is that you guys need to have a deep understanding of ACID. And also you need to master quad like DQL and DML. And then you need to have a good understanding of when to use TCL command. Yeah, we appreciate your feedback. Okay, don't forget to rate and review this session. Again, thank you so much, Sean, for your participation. If you guys have any questions, feel free to go ahead and ask. I'll be happy to provide you the answer if I can. Thank you.